Good morning, one and all. I'm Dr. Lalitha, Assistant Professor, Department of Electrical and Electronics Engineering, MLR Institute of Technology, Hyderabad. So, in today's video lecture, I'm going to discuss about the most important topic, that is DC generators. So, what is a DC generator? What is the necessity of learning about the DC generator? That all we'll discuss in this video. So, initially, let us start with the generator. So, what is a generator? So, initially, what is the necessity of learning about the generator? So, why you are learning about the generator means electricity had become such an essential part in our life such that we can't survive without electricity even for a minute. So, we are using electricity likewise. So, whenever there is a supply turn off, whenever we had turned off the supply, then what we'll do immediately, we'll turn on the inverter, or in the institutions or in any other offices, we'll turn on the generator. So while we are using the electrical energy in terms of generator, we have to learn about the basic concepts of the generator. So in this video, we are going to learn about the construction and how it will operate. So what is a generator? So generator is a device which is used to convert mechanical energy into electrical energy. So mechanical energy into electrical energy. So, mechanical energy is converted into electrical energy with the help of the generator. So, how this electrical energy will be come as output from the mechanical energy as input. So, this energy conversion is based upon the principle of production of dynamically induced EMF. Dynamically induced EMF. So, DC generators as well as DC motors both can run in a similar DC machine. So, now we'll see the constructional details of a DC machine. So, this is the construction of a DC machine. If we see this machine, so here we are seeing the outermost part of the DC machine. Here we are seeing like this. Now, this is the outermost part of the DC machine, which is called as yoke. Which is called as yoke. What is the yoke? What is the function of yoke? Yoke is nothing but the outermost part of the system. Protection. It gives the protection for the inner parts of the system, so that it will give the protection from the outside atmospheric disturbances or any other vibrations or any related sound or mechanical related losses are there. We can reduce by it with the help of the yoke. And moreover, the magnetic flux will be passed through this yoke. So, yoke plays a major role. It provides the mechanical strength, and whatever the magnetic field which is produced inside the generator will pass through this yoke. So, yoke plays an important role. So, next important one was, so first one what we had discussed about one was yoke. So, next one was field winding. Field winding. So, what is a field winding? So, these are nothing but the poles. So, North Pole, South Pole, North Pole, South Pole. These are our magnets, magnetic poles. So, why we'll use these poles means in order to excite. Means whenever I had given the supply to these poles, then what will happen? It will excite and magnetic lines of force will flow. So, according to it works on the principle of Faraday's law of electromagnetic induction. Faraday's law of electromagnetic induction. So, according to this principle, whenever a conductor cuts a magnetic field, an EMF is induced in the conductor. Whenever a conductor cuts a magnetic field, a conductor should be there, a magnetic field should be there, and there should be a relative motion in between this conductor and also the magnetic field. So, here let us suppose North Pole is there, here South Pole is there. Okay. So, magnetic lines of force always flows from North Pole to South Pole. North Pole to South Pole. So, according to the Faraday's law of electromagnetic induction, so if I had placed a conductor here, then what will happen? The conductor should move. Okay. While it is rotating the conductor. So, in one case, what will happen? It becomes parallel to the magnetic lines of force. The conductor. Let us suppose this is a conductor. So, while it is rotating, initially it will be a parallel to the magnetic lines of force. So, for parallel, there won't be any EMF induced. So, like this, the value is 0. While the conductor is getting rotated like this, then what will happen? the EMF will be induced according to Faraday's law of electromagnetic induction, because this conductor will move and it will come to the perpendicular direction to the magnetic lines of force. So according to the Faraday's law of electromagnetic induction, whenever a conductor cuts a magnetic field, means it comes perpendicular to the magnetic lines of force, and EMF is induced in the conductor. So the EMF induced will be maximum. So again, it is like this. Again, when it is rotating, it comes to the parallel position. In parallel position, EMF was not induced. So now again, the waveform will come to the zero position. So again, what will happen? Again, it will keep on rotating. The conductor will keep on rotating. And it became perpendicular to the magnetic lines of force. But the thing is that it came opposite to the direction of the previous one. So previously it came in the positive direction. Now it came to the same position but in the reverse direction. So that's why EMF will be induced but in the opposite direction. So that's why here we'll get the AC waveform. So again, what will happen? It became perpendicular. Again, while it is rotating, it comes parallel. Means it will come back to the normal position. So it will come to the zero position. So likewise, we'll get the sinusoidal waveform. So for that, magnetic lines of force, these are very much required. So for this, field winding plays a major role. So these four are nothing but the magnets: North Pole, South Pole, North Pole, South Pole. So we have to excite these magnets in order to produce the magnetic lines of force. That's why by using these wires, we are making the magnets to get excited by using this terminal box. Okay. Again, this magnet is shaped. See here, actually the magnet will be like this. But here what we are doing, we are shaping it like this. So why we are shaping it means in order to flow the free passage of flux. So flux means magnetic lines of force. See, so magnetic lines of force up to which the magnetic lines will exist. See, this is all nothing but the magnetic flux, right? So here, for the free passage of flux, if it is like this, there will be a free flow of flux inside. Otherwise, what will happen if it is like this in this magnet like North Pole, South Pole, then so much of flux will get wasted. So in order to overcome that, we are shaping these poles. So this one is called as pole core, and this shape is called as pole shoe. Pole core and pole shoe. These poles are divided into pole core and pole shoe, in which we are winding up the wires in order to give the supply, in order to make the magnets to get excited. Okay, next for the second one was completed, that is field winding. So the third one was armature. So what is armature? So see here we are seeing this like a division. See. So this is nothing but the armature. So what is the function of armature? Armature plays a major role in the DC machine. Inside this armature, there will be a slots like this. See, this is one slot, this is one slot, this is one slot. In the armature, there is slot. So inside the slot, we'll place the conductors. These are conductors. See here, these are conductors. In these armature slots, we will place the conductors. So all the armature conductors are grouped together in a specific manner, which is called as armature. Okay, which is called as armature. All the conductors are grouped together. Means we won't leave like this, because while the machine is rotating, these armatures will come out. So that is a loss and it is not at all safe. So what we'll do, we'll connect all these conductors in a specific manner. So two types of connections are there, which we'll discuss in the further slides: lap winding and wave winding. So in these two type of connections, it will get connected. Means these armature conductors will get connected. So these armature conductors, while it is rotating, so it will follow the principle of Faraday's law of electromagnetic induction, because we are using the poles here. So we are exciting the poles here so that the magnetic lines of force will flow. In that magnetic lines of force, these conductors, while it is rotating, so it will come parallel, perpendicular, which I had told you previously, and EMF was induced according to the Faraday's law of electromagnetic induction. So that is the purpose of armature and armature conductors. So what is the function of commutator? So commutator will collect the current from the armature. what is the function of commutator? It will collect the current from the armature which was generated. So these are nothing but the brushes. So from the brushes we will connect to the load. From the brushes we will connect to the load. This is the basic construction of a DC machine. So this DC machine can be used as a generator as well as a DC motor. So now we will see the each part in detail. So the DC machine mainly consists of two parts, means all these comes under these two only. So one is called stator, which is nothing but the stationary part, rotor is nothing but the rotating part. So we'll come linely across the parts which we had discussed previously. So first one was yoke. So what is the yoke? As I told you, the outermost part of the DC machine is called yoke, which is giving the protection for the inner parts of the machine, and it provides the mechanical strength. Means in order to place the poles, it gives a support to the DC machine, and also it carries the magnetic flux which is produced by the field winding, because the field winding, the poles are connected with the yoke only, so that the magnetic flux produced by the field winding, it will carry the magnetic flux. So next one was, it is made up of cast iron or steel. That is the most important thing. It is made up of cast iron or cast steel. That is about the yoke. Next, coming to the pole or pole shoes. Pole shoes or pole core, everything comes under poles only. So poles means North Pole and South Pole, which we had discussed before. So these poles are joined to the yoke with the help of the bolts or with the welding. So generally we'll connect with the bolts. So these carry the field winding and the pole shoes are fastened to them. So these pole cores serves the two purposes. The first purpose was they support the field coils. The main purpose of the poles is to support the field coils, and next one was to transfer the flux, to spread out the flux in the air gap uniformly. For that only we are designing the poles like this. Otherwise the poles will be like this only, North Pole, South Pole. But we are designing the poles like this in order to flow the free passage of flux. So next one was field winding. So what is a field winding? So field windings are former wood and are placed on each pole and are connected in the series. So they are wound in such a way that whenever they are energized, they form the alternative North Poles and South Poles. Okay. These windings are made up of copper, because the conductors, the main conducting material which we will use are copper. So next one was coming to the armature core. Armature core. Next one was armature winding. So here this is the picture of the armature. This is the picture of the armature. So see here we can see the armature slot. Inside the armature slots we are placing these are all nothing but the conductors. These are nothing but the armature slots. Inside the slots we are placing the conductors. Okay. So armature core. So armature core is nothing but the rotor of the DC machine. So it is having a slots in order to carry the armature winding. So in the armature, as I had shown you, so there will be a slots like this. So inside the slots there will be a conductors. So see here, these are the slots, these are the conductors, these are the conductors. Okay. So why we are keeping like this means, in order to, these are having eddy currents mainly. Eddy currents means nothing but circulating currents. Circulating currents means inside the core, what will happen means, the circulating currents will get developed. So the direction of this current will be opposite to that of the direction of the original current. See, the current had been developed inside the conductor. The current have been developed inside the conductor. If this is the flow of direction in the normal direction, and the eddy current direction will be opposite to that of this direction, so that they both will get hit and total current will get reduced. So that is a great loss to us. So in order to reduce these eddy currents, we will laminate these with a circular steel discs. Circular steel discs in order to reduce the eddy currents. So we will also provide the air ducts, so that there will be a free passage of air, so that it will get cool automatically. So next one was armature winding. So armature means which is nothing but a conductor. Inside that there will be a conductors. So it will be wound with a copper coils which are rests in the armature slots. So these armature conductors are insulated from each other, because it won't get a joint. There will be an insulation between, because we will give the connections. So we will give two types of connections, lap winding and wave winding. Lap winding and wave winding. So see this type of connection. One end is connected to some other end. So likewise this end of connection, this connection is called as lap winding and this connection is called as wave winding. Is called wave winding. So we had designed the armature here in the armature slots. These armature slots are connected either in the lap winding or in the wave winding. In these two types we can connect in any of those. So this armature winding can be connected in two methods, lap winding and wave winding, and double layer lap or wave windings are generally used. So a double layer lap winding means that armature slot will carry two different coils. Two different coils will have in one slot. So next one was coming to the commutator and brushes. So what is a commutator? What is a brush? So the main purpose of the commutator is in order to collect the current from the armature. That is in the case of DC generators. In the case of the DC motors, the commutator helps in providing the current to the armatures. Providing the current to the armature conductors. So in the case of DC motor, commutator helps in providing the current to the armature conductors. So a commutator consists of a set of copper segments which are insulated to each other. There will be having insulation between any conductors because no two conductors should get overlapped each other. So the number of segments is equal to the number of armature coils. So each segment is connected to an armature coil and the commutator is fixed to the shaft. So see here we are seeing the commutator figure. Okay. So each segment is connected to the armature coil and the commutator is fixed to the shaft. So if we rotate the shaft or if the shaft is getting rotated, whole the DC machine will get rotated. That means machine will move. If this shaft is getting rotated, the armature which is connected, it will also get rotated and magnetic field will be there whenever the conductors is getting rotated. Then according to the Faraday's law of electromagnetic induction, the EMF will get induced. So the brushes are usually made up of carbon or graphite. So these will stay in the commutator segments and slide on the segments when the commutator rotates, keeping in the physical contact to collect or to supply the current. So these commutators are connected to the brushes and these brushes are connected to the load. So as we had discussed before, according to the Faraday's law of electromagnetic induction, whenever a conductor is placed in a varying magnetic field, whenever the conductor comes perpendicular to the magnetic lines of force, an EMF is induced in that conductor. So the magnitude of this EMF induced, how much amount of EMF got induced here by using this principle, can form the EMF equation of a DC generator, phi Zn by 16 to P by A. So if the conductor is placed with a closed path, the induced current will circulate in the path because currents only flows in the closed circuits. So in a DC generator, the field coils will produce the electromagnetic field and the armature conductors are rotated into the field. So why it is getting rotated? So one should be fixed and one should get rotated. Then only the conductor will come either parallel or perpendicular to the magnetic lines of force. So the direction of the induced current which was produced is given by the Fleming's right hand rule. Now we will see about the need of the split ring commutator. So what is meant by split ring and what is the purpose of using split ring in the commutator, that we will see now. So here North pole, South pole, two magnets are there which we are taking from the field winding, and in between this the coil is there. Coil means, see, one coil is equals to two conductors. So AB is one conductor here, CD is another conductor here which is connected to the commutator here. See, this is all commutator only. So split ring commutator means we are dividing this commutator into two equal halves which is separated by the insulation. So here we are connecting it into two parts and we are naming it as F and we are naming it as E, and these are nothing but the brushes. From the brushes we will connect to the load. So initially what will happen? We will give the positive supply only. So the positive current will flow like this, and this is the closed loop, and here the closed loop will get, so that the positive For the waveform, positive sign will come. Positive waveform will come. Now what will happen? According to this Faraday's law of electromagnetic induction, so whenever the EMF was induced, whenever a conductor was placed in a magnetic lines of force and EMF was induced, so it will come parallel, perpendicular, so that we will get the sinusoidal waveform here like this. But the thing is that this is a DC machine. So DC generator means unidirectional flow of current should be there, not the sinusoidal waveform. That means we have to convert this AC waveform into the unidirectional flow. Means this part should not be there. Means we have to change this part also to the upper part. So for that purpose, we will use the split ring commutator. So we have divided it into two halves, two split rings. We are splitting it into two parts. So the same here, see FE is there, here EF is there. That means what we are doing here, we are just interchanging the sides of this commutator. See, F part came here, E part came here. Remaining all I kept the same. So as F part came here, the conductors which is connected to here came this side. The conductors which is connected here came this side. Means just we are interchanging it. So actually what should happen here, positive supply is there. Next here negative supply will act here and negative waveform will come. But we don't want the negative waveform. We want only the positive waveform. That's why what we are doing, we are interchanging this. And see here we are forcibly making the positive current to flow in this direction, so that the loop will become like this. The loop will become like this. So here what we got? We got again the positive waveform only for these two terminals also. For CD conductor also we got the positive waveform only. So we are forcibly turning and we are making the positive flow of current inside the coil. So the waveform will become like this. So again, if the coil was turned or if this conductor was turned, again case 1 it will come. So like this. Again after that these two will get interchanged and again it will come like this. Means we are forcibly making the waveform like this into the waveform like this. So for that purpose, means making the from bidirectional to the unidirectional flow, we are using the split ring commutator. And finally these are the pressures, and from the pressures the load will get connected. That load, whatever may be the domestic load or industrial load, whatever it may be, that is the load. So this is the constructional details of DC generator, the operation of DC generator and how it will get and how the power will get into a DC generator and how it will be connected to the loads. Okay, those all we will see in the further videos. Thank you.